Good morning, students. Our today's topic is the torque acting on an electric dipole when it is placed in a uniform electric field. As we know that a uniform electric field is represented by equidistant parallel lines like this. Okay, consider this arrow shows the direction of electric field. Now, in this uniform electric field, if we place an electric dipole, which is an arrangement of a negative and a positive charge, say this. Okay. Now, when this dipole having charge minus q and plus q separated by a distance 2a, let these charges are at point A and B. Okay, let the dipole is acting at an angle theta with the electric field, or we can say the dipole moment is at an angle theta with the electric field. So as we know that when charge is placed in an electric field, it experiences a force. Then at point A, as it is a negative charge, then there is a force which is acting opposite to the direction of electric field, and this force is q into E. Okay, as charge here is negative, so we can say it is minus QE, and similarly at positive charge the force is in the direction of field, which is plus q into E. Okay, now due to the strength of this dipole, these two forces are opposite to each other and equal in magnitude, but because these two forces are acting at different points of the dipole, that is why they form a couple. Okay, and this couple is tends to the align this dipole in the direction of field. Okay, that is why there will be a rotational force acting on this dipole, and this rotational effect or this rotational force is called torque. Okay, so we want to calculate an expression for this torque. Okay, now as we stated earlier that when dipole is placed in this field, then the forces on plus charge, that is force on positive q, is equal to plus q into E. Similarly, the force on negative charge is minus q into E. So net force on charges, or we can say dipole, is, that is plus q into E minus q into E, which is equal to 0. But as we can say, there is some rotational effect, so there exists a torque, and the torque is defined as the product of either force with the perpendicular distance between the line of force. Either force, or we can say the either force into perpendicular distance between the forces. Okay, so here one force is along positive x-axis at point B, and another is in opposite to that at point A. So in between these two lines, okay, so we can say these are the line of action of the forces, Okay, so the perpendicular distance between these two lines is this one. We can draw this line like this. So we can say a line BC is the perpendicular distance between the two forces. Okay, now from the diagram it is clear that if the hypotenuse of this triangle is 2a and this perpendicular is BC, so we can say perpendicular by hypotenuse is equal to sine of theta, or we can say this BC, which is equal to sine theta into AB, that is 2a. So the perpendicular distance between the two forces is 2a sine theta, and hence tau becomes force, that is F into 2a sine theta. As any one force of these two, that is plus q or minus q. So we can write here force is q into E into 2a sine theta, or we can write it as q into 2a. This quantity is represented by p, E sine theta. Okay, where 2aq is equal to p, as we stated in the previous topic. Now, as dipole moment is a vector, electric field is also a vector, and theta is the angle between these two. Okay, so we can write this as the cross product of these two vectors, because we know that p cross e is equal to pe sine theta. So we can write it as tau must be equal to p cross e. As it is a vector product, that is why torque is also a vector. Okay, so the direction of this torque is also obtained by the cross product of two vectors gives the direction of the third vector, which is obtained by right handed screw rule. Okay, so now also we know that this dipole makes different orientation with the electric field. So with the variation of this theta, the value of this torque is also changes. Now for the consideration of this theta, let us consider a case 1. Okay, case 1 is that, as we stated earlier, that the force acting on this dipole is tend to align the dipole in the direction of field. Okay, so when this dipole is line the direction of field, it means this theta becomes 0. Okay, so now first case is that when theta is equal to 0, then torque, that is p e sine theta, becomes p e sine 0, or sine 0 is 0, that is tau is 0. It means torque acting on the dipole is 0. In this situation, the dipole is said to be in equilibrium, or this equilibrium is called stable. Okay, so the dipole is said to be in stable equilibrium. Okay, the second case second is, now if theta is 180 degree, that is the dipole moment of the dipole is opposite to that of electric field, then the torque is equal to pe sine 180 degree. Again tau is 0, and the dipole is said to be in unstable equilibrium. In third case, as we know that if theta is equal to 90 degree, then the value of sine theta is maximum, or we can say 1. So torque becomes tau is equal to pe sine 90, that is pe into E, or we can say torque is equal to PE. That is the maximum torque acting on the dipole. Okay, so this is all about the torque acting on the dipole. Thank you very much.